Another very common application of exponential functions is in modeling growth of things. Human cells, or human beings, we all start out as one cell. We become 2, then that becomes 4, that becomes 8, that becomes 16, and so on. That would be the 2 to the x function. In this one, we're looking though at bacteria, and specifically the E. coli, very common in our bodies. And we are told that we're starting with 3,000 bacteria in a dish at one time maybe, and we're going to call that time 0. And then t minutes later, the number of bacteria present would be 3,000 times 2 raised to the t over 20. Okay, so that's our formula. We want to know how many bacteria are going to be present 30 minutes later. Well, they're telling me the t, I just simply plug it in. Now I've written it out here. How do I put it in my calculator? Well, I would do 3,000 and times 2 and then raise 2. Well, 30 over 20, I could either do that in my head, it's 1.5, or if I don't want to have to do that calculation, I'm going to use parentheses 30 divided by 20. And the reason I have to use the parentheses is because of order of operations. I want it to get this answer and then use it as the exponent. And we get our answer of about 8,400 or 8,485 bacteria. Then it says they can cause infections when their number reaches 100 million. How long would it take for that to be possible? Okay, well, I put 100,000 over here for my answer equal to our original formula. All right, now I don't have the algebraic skills yet to solve that, so I'm going to use my calculator. Put in your 100 million on one line for your y, and another y we're going to have be this right-hand side. And again, notice that I put my exponent in parentheses there. For my window, well, x, the same as t, is representing time in minutes. So 0 to 360 would give me up to 6 hours of time. That's probably pretty reasonable. You know, you hear all those warnings around Thanksgiving to put the turkey away after so many hours. Well, 6 hours would be well beyond what they always recommend, so I think that'll probably be a good number. I'm going to use a scale of 60 because that means it's hourly increments. What about for our y's? Well, I like to start at 0 just because that's me, and I know that I have to go up to at least 100 million. I want to go pretty well beyond that, so I chose to go up to 150 million, and then I made my increments 10 million. If you don't want to change the scale, don't worry about it. It just makes this line really kind of thick. Okay, so I've got my calculator here, and I already put those in, changed my window, and here's our graph, same as I've got on screen. Now, how did I get the answer here? Well, second trace takes me to that calculate menu, and we're looking for the number 5, the intersect. So it says first curve, is this it? Yes, it is. Okay, and then can you see it's kind of blinking down there at the bottom? It's saying, is this your second curve? Yes, that's it. All right, and now they want me to guess where I think that intersection point is, and right close there, hit enter, and we get our answer. So it's about 300 minutes, and that would be the same or equivalent to 5 hours. So if you put it away in 4 hours, you're probably really safe.